Hello, friends, welcome back. So, today in our tree series, we are continuing, and as mentioned in the last video, today we are going for tree traversals. So, there are three types: in order, pre order, and post order. But before that, we must understand what do you mean by a traversal? What is a traversal, right? So, moving in a tree is a traversal, right? And it should be such that either you follow some path that you want, or you should be able to visit each and every node of the tree. So in this video, we are specifically going to focus on the binary tree traverse. I already told you what is a binary tree in the last video. Please check the definition of a binary tree, and we are going to focus on that only. We are not focusing on tri-E, B tree, or any other type of trees. The traversals that we are going to learn today in today's video are specifically for binary tree. Okay. So first of all, let's have a formal definition. So what is a traversal? So we can say that moving in the tree from one node to another, and we must say that we must start from root so that you cover each node and or the desired path. So I would say let first take an example how a traversal is done. So I keep the definition here. Suppose this is your tree. I will label it as any random numbers. So this is also a binary search tree if you can identify this. So let us see, let us try to traverse it, right? So I will try to use a different color for better explanation. So you always know that we have to start from root. Let's assume that our I is right now at root, and we can see the root. Next step that we can do is we can say, assuming left, move towards our left part, and with this our I will also move. Now we are at 10. Again, we have the option of either moving to left or right. Let's say we move to right, and when we are moving, our I will also move. Now, what is the option with us? The option with us is to move back. So what we will do is we will move back from here. Now, when moving back, our current location for our I will again be 10. Now, can you see that we are at position 10 twice? Twice we came at 10. We can move to 5, but let's say we are not. We will move again back to 30 root. When doing so, obviously, our I will again be on 30, and we are again visiting 30. Similarly, if we keep on moving in other direction, and when we will go up, we will be visiting each node twice. This is the traversal. If you visited a node, then you must return back. You cannot jump from one node to another. No, it is not allowed. You have to follow the branches that are connecting the nodes. And you have to go back in the same path that you came. So these two are very important points that you must remember while traversing. First point is must follow the branches to move from one node to another. And second point, same path will be followed in reverse order to move back. So in this example, if I remove all this thing and try to give you a new path, now I'm not moving I, because you have understood the concept. So assume you move this one, then two, then three. So when you go back at 20, you came from 10. So you will return to 10. You will not go to 5. So you always return to your parent, right? Okay. So I think with this, we should be fine with moving to our traversals. First of all, we will understand the in-order traversal. And I'm going to explain this only. Because if you understand any of the one correctly, then others are just cakewalk. So I will again draw my tree. Instead, I should copy the above tree. I think it would be a good option. If I can just copy this tree down, and let's have few more nodes. I think this should be enough. So before going for in-order traversal, let's understand the basic concept that would be same for all the three. What it will be. When right now where you see the your I, it is at the root, right? It is the root. So when we are at any node, right now we are at root, but when you are at any node, you always have three options to perform. What are your three options? First option will be you can process the node. Process means you can print it value, you can call some function, anything that you want to do with that node, with the current node at which you are. So you can, I'm just using the word process, right? We will use a print. We will call the print function to print its value. Your second option can be you move towards left, right? I don't want to do anything, or if I'm done with my processing, I will move left. Or my third option can be I will move towards right. These are the only three options that are available with me when I am at the node. And once these three options are completed, I will, once completed, return to parent. Why? Because you have to go back to the same path that you came from. So when you are at, say, node 50, you are done with processing, you are done with left node, you are done with right node, you have to move back toward the parent. I can say that, okay, this could be the fourth option, or that you have to do after these three steps are completed. So one thing you can say, that when you say I will return back, so you can you see that we are using recursion here. So if you are not aware what is recursion, so I would request to please look at the corresponding lecture. It has been covered in detail. Recursion means I am calling my same function again and again. That is recursion, right? And when I'm done, I will return back. Now, what is an in-order traversal? In-order traversal means this process part should be in of what? In means between. In means between of what? Of other two options that are written. So in order traversal, you say for each node, first of all, so let's say I have a function in order traversal. Let's say I have root, right? So what I will do is, in order traversal, I said process will be in between. So first of all, I will move left. I will call my function in order with root dot left. Then I have to process. Let's say we are printing. I will say print root dot, assuming it is having the member data, and then again root dot right. That's it. Done. This is the only function for in-order traversal. Only 4 lines of code. So simple, right? Don't worry. I will explain each and every step what we are doing. For pre-order, just take print at the first step. And for post order, take print at the last step. Because it is post, so it is at the last. Pre at the beginning. In between. That's the only difference in the code. But it will make a huge difference how you are moving in the tree. But here, we are going to focus entirely on our in-order traversal. Let's start. Okay, we have to perform what I see. Carefully note I have written. For each node, I have to perform these 3 steps at each node. Okay, so I will label my 3 steps. This is my step number 1. This is my step number 2. And this is my step number 3. So when I am at each node, I am going to perform these 3 steps. So right now I am at root. Have I done my first step? No. So I will first perform my first step when I am at root. So first step I will perform. I will write 1, 2, 3 at every node so that you remember if we have completed or not. Because if you are not familiar with recursion, it would be a bit hard to understand. Okay. And after this function completes, we will return to parent. That's common, right? Whenever a function completes, it returns to its parent. Great. Now, I'm at root. I have done my first step. So what I will do is, I will cut it out. As soon as what is my first step? Move towards left. So when I am moving towards left, I should also move. I have moved toward left. So now I am node 10. Have I performed my first step? No. I will cut it down And as soon as I cut it down, that means I have to move towards left. Again, have I performed my first step? No. I will cut it down. But now there is no node available. So that means in our function, we have to write another line. If root is null, then return. This line I have added at the top. And you can say this is the base condition for the recursion function to break. Okay. So when we will say that move first is done, we will try to move, but the function will return from here. So we can mark it as done. Now, what is the see where our I is? We will try to move towards the left, but the function will return because there is no left. Okay. So first step is done. There is no left, nothing to do. Our function will return. Now, what is the second step for where our I present is? It is to print. So I will just print 5. Second step also done. What is the third step? Move towards right. We will try moving towards right, but there is no right. So the function will return from the base condition. And we can say that our third step is also done. Okay. And as I mentioned, whenever all 3 steps are done, that means our function completes. So our control will move back from where we came. Very, very important. That's what I mentioned. You will go back in the same path from which you came. Now, when we are at when we are at 10 node, we already completed the first step. You can see that I have cut the first step, that we have performed it. So we have to perform the second step now. That is I have written these numbers so that you can remember at which state our recursion function was. What was our state at each node when we are recursing, so that you can visualize the recursion in your mind. Okay, so for node 10, current node where our I is, we have to print it. Awesome. Done with the second step. Third step, move towards right. Okay, the right is present, 20 is present. So what we will do is, we will move towards right here. And we will also make sure we have performed our third step because we have moved towards right. Again, at 20, we have first step to perform because we have never visited 20. So when you are at 20, left node, move left, we will move towards the left one again. We will move towards the left, return from the base condition. Then we will print. Great, we will print 15. Then we will move towards right, return from base condition. And then we will return to the parent from where we came. So what is our state at 20? We have only processed the first step. So now we will do the second step and we will print 20. Then we will perform third step. There is no right node. We will return from the base condition. All 3 steps performed, we will move towards its parent from where we came. We came from 10. At 10, we have performed all the steps. Okay, so we will go back to its parent from where we came. 30. At 30, we have only done first step. So we will perform second step, print. Then we will perform third step and we will move towards right? Now at 50 also, we have not covered anything. So we will take first step, which is moving towards left. Do we have a left child? Yes, we do. So we will move towards 40. At 40, do we have, okay, perform the first step. Do your left child? No, we will return from base condition. Let's perform second step, print 40. Then let's perform third step and move towards our right child, which is present there. So when we are at 45, perform first step, no left child, return from base condition. Perform second step, print it. Perform third step, return from base condition. Entire 3 steps are done, return to its parent. Okay, let's return. At 40, all steps done, return to its parent. I am at 50 now. So I will, at 50, I will perform second step. I will print 50. Then I will perform third step. I will move towards right child. At right child, I have not performed any function. So I will perform first step, no left child, return from base condition. Perform second step, print it. Perform third step, no right child, return from base condition. At this moment, we are done with 3 steps, no problem. We will return to its parent. All 3 steps, return to its parent. All 3 steps, return from the function from where this was initially called. Are you able to follow the steps? If not, please rewind and see, I have explained at each point what is the condition, current state of our function stack, at which point we were. See it again and again until this becomes clear in your mind. You should be able to visualize in your mind where I am currently and what is my current state. This I have explained in too much details. When we will see pre-order and post-order in next video, so I will be a bit faster because I'm assuming till then things will be very much clear in your mind and you are visualizing as I am going to explain. Last thing in the video, you might have noticed that whatever we have printed, this is in ascending order. We were just printing. I have not written it deliberately in ascending order. I was just writing it. And this is a BST. This is a BST. So that means Inorder Traversal in BST gives you data in ascending order. You remember in last video I told you that one of the property or application of BST is that it keeps the data in sorted order. And I also mentioned in this tree, I do not see any order being maintained. Yes, this is the order that is maintained by BST. So when you do the processing in this format, in order, so at that moment, by this method, you get the data in ascending order. Okay, I hope you like this video. Please do let me in the comments below if you have any questions. I will see you again with the leftover ones, pre-order and post-order in next video. Thanks for watching. Take care. Bye.